Hey guys, welcome back. We are covering TEKS 5.3c, and that has to do with dividing, but not only dividing. Your digits in your divisor are going to be a 2-digit, and the digits in your dividend will be either a 3-digit number or a 4-digit number. So your objective is I can solve for quotients when I have a 2-digit divisor and a 3 to 4-digit dividend. Okay, so by the end of this segment and also this unit, you should be able to, as a 5th grader, get a quotient, solve for a quotient when your divisor is 2-digit and your dividend is either a 3-digit or a 4-digit number. So again, we always start off small, so let's start off with what was in our modeling segment. 12 divided by 3. 12 divided by 3. Remember, and we're always going to say this. This is our divisor. It's O. It has an O in it, so it's going to go on the outside. And this is our dividend. It's going to go on the inside. So 3 divided into 12. Well, sometimes standard algorithm can be a little bit daunting or a little bit scary to people, because you have to go, if it doesn't go into the first few digits, you have to then move over a place value. Well, that's nothing new. There's nothing to be scared of, guys, is because we know that 3 groups of what can go into 12. And from our modeling and from just knowing by the time you're in 5th grade your multiplication chart, 4. 3 groups of 4 can go into 12. But we just know that. But you can also say to yourself, oh, 3 groups cannot go into 1. 3 groups cannot go into 1, but they can go into 12. Did you see that? They cannot go into 1, but they can go into 12. And so we're going to use that exact same questioning or strategy to take us through some other numbers. So let's see what happens when we continue to have a 1-digit divisor, but then, I don't know, a 3-digit dividend. Take 129 divided by 3. 1-digit divisor into a 3-digit dividend. 3 cannot go into 1. 3 can go into 12. We know that 4 times. 4 times 3 is 12. That's 0. Bring down the 9. How many times can 3 go into 9? 3 times, correct. 3 times 3 is 9. No remainder there. So 3 groups of 43 can go into 129. So that is written, of course, so that's saying that 3 groups of 43 create 129. Okay. Well, look, guys, y'all were so successful with this last one. Let's just add one more digit to the divisor and one more digit to the dividend and see what happens. I bet you can do it. And as a matter of fact, I know you can do it. So let's say 1,290. We now have a 4-digit dividend divided by 33. This is now a 2-digit divisor. Okay, let's do the partial quotient first. And I want to clear something up concerning partial quotient versus standard algorithm. What I noticed in class is when we were going through this, and some of you chose to do the partial quotient method, what was happening is y'all were getting it confused with steps of this standard algorithm. So this is what I want you to start doing when you decide in your head that you want to do the partial quotient method or strategy. We have 33, the divisor, going into 1,290, the dividend. Of course, with partial quotient, we draw this long line down to the side. Some of you were taught that this was hangman division. Some of you were taught that this was the big 7 division. But here's the deal. This is the point that I want to make. Whatever number that you put on this side here and you multiply by your divisor, that number needs to go under the entire dividend. So your place values need to line up. You are not, I repeat, you are not bringing down any values of the dividend when you are doing partial quotient. So when you're doing partial quotient, I want you to draw a line all the way from one end of the dividend to the other end of the dividend, because I want you to know that you have to line up the values. So, what does Miss Guidry always like to start off with when we're doing partial quotient? That's right, 10. I can never go wrong with 10. So 10 times 33 is 330. So I'm bringing that ones place value of 330 under the ones place value of the dividend. I'm bringing the tens place value of 330 under the tens place of the dividend. And I'm bringing the hundreds place value of 330 under the hundreds place value of the entire dividend. And then I can subtract. So I'll get 0, I'll get 6. And guys, you can do it a couple of ways. I see 12 minus I see 12 minus 3. You may feel comfortable with regrouping, making that 0 and then doing 12. But you get 960. Okay? So, we're still not there yet, are we, guys? Okay. So, we did 10. I know 330 can be taken away from 960. Let's try multiplying by 20. 20 times 33 gives us 660. Again, your place values need to line up. Ones place, tens place, hundreds place. And then we get an easy peasy subtraction problem. Now we have 300. Now, I know 10 times 33 is going to give us 330. And that's larger than 300. So, what do you say us going to 9? Let's try 9. Let's go to the side, do our little math. Neat side math, guys. Oops, what am I doing? That's not so neat. So much for saying that. 33 times 9, that's 7. Carry the 2. That's 27. plus 2 is 29. 297. Okay. 297. I know that 3 plus 997 is going to give me 300, but for those of you who want to still do the math, I've got to go all the way to the hundreds place and regroup all my values. But look, I still get 3. So, we add these together in partial quotient. 0 plus 0 plus 9 is 9. 1 plus 2 is 3. I line up my value. 9 goes over the ones place. 3 goes over the tens place with the remainder 3. Guys, you did that. You did a great job. Do not let a 2-digit divisor intimidate you. You know the processes in partial quotient. If you're not familiar with your multiplication facts of a number like 33, partial quotient is there to help you. Now let's see how this looks with standard algorithm. 1,290 divided by 33. Our dividend goes in, our divisor, it has an O and it goes out. And this time we're doing the standard algorithm. $33 is my divisor. It's outside. 1,290 is on the inside. 33 cannot go into 1. If I have 1 and I want to separate it into 33, I can't give you powers of 33. I can only give you powers of 1. Remember, magical powers. 12. Let's go to the next value placement. 12. You can't get 33 out of 12. So that's a no-go. So now we go into 129. Yes, 33 can be divided into 129. And the question is, how many times? Well, if I multiply 30 times 4, that gives me 120, but I have 3 of these guys times 4 left over, so that would be multiplied by 4 too, and that would be too much. So let's go down. So we would put a 3 over what we would put a 3 right here. 3 times 33 is 99. So let's see what happens. We'll get a 0. And again, guys, I see 12, but you may want to regroup. 12 minus 9 is 30. Then we bring down the what? See what I'm saying? In standard algorithm, you divide, multiply, subtract, bring down. Not so in partial quotient. So we bring down the other 0. Now we already know that 33 times 10 is going to give us 330. We don't want to do that. So we'll go 1 down. We'll say 9. 9 times 33 is 297. Still lining up our place values, guys. And that gives us 3. So those are the two ways that you could have done that. Again, do not let a 2-digit divisor intimidate you, because you know what you need to do. First thing, you need to decide which strategy are you going to use. And once you decide your strategies, you're going, whether it be partial quotient or standard algorithm, then commit to the ways in which you're supposed to do it. Okay, guys? If you need any more help, you know who to call. I'll see you in the next segment. Take care.